Good day everybody. I am Rene Boise Mello Jr. and today we will discuss about leather gelatin and glue. Before I will proceed for my discussion. Disclaimer, I do not own any information such as text and pictures here, everything is properly cited at the end of my presentation. Leather is one of the oldest of the commodities on the present-day world market. It has been called the most historic of useful materials. The art of leather manufacturing from hides and skins antedates, by centuries, any of man's scientific knowledge of chemistry. Specimens of ancient Egyptian leather have been found which are claimed to be at least 3,000 years old. As you can see at the bottom second picture, it is an underwear made out from leather years ago in Egypt. Animal skins can be classified into hide, skin and kip. Technically, the term hide is applied to the skins of larger animals such as bulls, horses, cows, and oxen. The term skin refers to skins of goats, sheep, calves and to smaller animals. Very often the term kip is used for the skins of animals smaller than a full-grown calf. This is the layers of skin. Animal skins as received by the tanner may be divided in three layers. First, the epidermis. Second, the derma or corium. And lastly, the flesh or fat. The epidermis, comprising about 1% of the total skin, is the outer layer and consists chiefly of the protein keratin. The hair which grows through both the derma and the epidermis is also largely keratin. The derma is the leather-forming part of the skin and consists mainly of the proteins collagen and elastin. This layer is dense and chemically resistant, thus allowing the epidermis to be readily removed by chemical means. The flesh is a thin layer, mostly adipose tissue, which must be removed to ensure tannin penetration on both sides of the corium. The unit processes and unit operations. Figure as shown is the necessary steps in the manufacture of leather. These steps may be broken down into the following unit operations and unit processes. First we will discuss the legends that we used in this diagram. First it is for the unit process. Second, it is for the unit operation. And lastly, it is for both unit process and unit operation. The skins are opened, examined and if of foreign origin disinfected. The hoofs, ears, tails etc. are trimmed off. In the soaking pit the skins are water soaked for 12 to 24, or 1 to 2 days. The flesh is removed by a machine equipped with a spiral-bladed cylinder and beaming process. In the liming process, the skins are partly dehaired and treated with the saturated lime solution plus certain accelerators such as sodium sulfide or sulfahydrate and dimethylamine for 3 to 7 days. Any hair remaining is removed by machine and hand scraping on the scudding bench. Then the hides undergoes bathing process with the temperature of 90 degrees Fahrenheit. The clean dehaired hides are treated with certain enzymatic preparations for 2 days to soften the skin and remove the lime. The hides are now then rinsed in the rinsing vat. After rinsing, the hides are ready for tanning. There are two tanning methods, which are vegetable tanning and chrome tanning process. After tanning process, the leather is ready for the finishing operations. Finishing operations are somewhat similar for both methods of tanning. The tanned hides may be dyed. The leather is stuffed with oil. The leather is split to produce a thinner, more supple product. Gloss is developed on the surface of this leather by ironing and jacking the leather with a glass cylinder. The jacked leather is dried, embossed, and measured. Preparation of hides for tanning. The first step in the tanning process is the inspection of the hides for defects as they come into the tannery, cutting off of ears and ends, the cleansing of the hides from dirt, manure, and salt, and restoring the hide to a natural soft hydrated state by paddle washing, drum washing, or soaking in vats. Paddle washing. Usually about 9 feet wide and 5 feet deep, containing a rotor or paddle 5 feet in diameter. This paddle operates at approximately 15 revolutions per minute. Advantage: the equipment is cheap and easy to construct, uses little power, and is not so liable to injure the hides as is the drum method. Disadvantage: the necessary high ratio of water to hide, about 3 pounds of water per pound of hide, and the required hand removal of the hides from the paddle. Drum method. about 8 feet in diameter and internally fitted with wooden pegs or shelves. The drum is rotated and gives the hides a tumbling effect during washing. The chief disadvantage of this method is the danger of damage or rub marks on the hides. Liming. Liming is a means of loosening and removing the epidermis and hair from the hide and is usually done in wooden or concrete vats. The hides are tied together and placed in the vats containing water with 10% of the weight of the hides in lime, and 2% of the lime weight in sodium sulfide, which acts as an accelerating agent. Chrome process and vegetable tanning. Tanning leather is an important part of the leather-making process as it prevents the hide from rotting and determines the durability and final characteristics of how the leather can be used. When leather goes through the tanning process, its protein chemical compounds are stabilized, which prepares the leather for manufacturing. Although there are 4 distinct common tanning methods, each of which creates a different type of leather in texture, durability, and aesthetics, the 2 most popular forms of tanning used are vegetable tanning and chrome tanning. The vegetable tanning process involves the use of tannins, as well as other ingredients from vegetable matter to tan the hide. Some of these vegetable matters include bark prepared in mills, wood, leaves, roots, fruit, and other similar natural elements. Chrome tanning is for light leathers, and the chief use of vegetable tanning is for heavy leathers used for soles and belting. Vegetable tanning lasts 2 to 4 months, while chrome tanning it lasts for 1 to 3 weeks. In color, vegetable tanned leather has results usually in russet browns and black, while chrome tanned leather results in wide variety of colors including bright colors. In vegetable tanning, results in strong and firmer. On the other hand, chrome tanning results in supple and soft. In economy cost, vegetable tanning is costly than chrome tanning. Vegetable tanning is usually done in wooden, red pine, vats 8 by 7 by 5 or 6 feet deep which contain the tanned liquors and hides. Since the hides remain in the liquor for 1 or more months, many vats are required, and they must therefore be cheap and durable. Hides first enter the oldest, weakest tanning liquors in order to prevent complete plugging of the surface pores and subsequent pore penetration of the tannins through the skins by a strong liquor. Sometimes the hides are placed on rockers or paddles for the first 15 to 20 days to give them a gentle movement in the liquid, which tends to accelerate the tanning and make a more uniform leather. As you can observe, vegetable tanning took so long. Any attempts have recently been made to speed up the tanning time and to shorten the expensive and mellowing in tanned liquors, such like using different reagents like formaldehyde or increasing temperature or alternation of pressure, but it attained no success. The vegetable tanning process consists of the following procedures. The prepared skins are treated with organic acids to neutralize any residual lime. The tanning is carried out in several tanning baths starting very weak to prevent case hardening and becoming progressively stronger. This requires about 1 month. The skins are then allowed to rest in a vat containing tan bark for 60 days. Chrome tanning is usually subdivided into 2 processes, the 1-bath process using basic chromic sulfate and the 2-bath process using sodium dichromate. However, in each case, chromium salt is used in place of the vegetable tanning agent. The chrome liquor for the 1-bath process is usually made by reducing an acidified solution of sodium dichromate by slowly adding a solution of glucose to it or by bubbling sulfur dioxide through the dichromate until the reduction is complete. In the chrome process, the properties and composition of the finished leather are greatly influenced by many factors that can be controlled during tanning. Such factors as salt concentration, temperature, agitation, time, and proportion of protein to liquor are very important in the effects on the leather produced. In fact, it seems that the number of possibilities of operation and final results in chrome tanning is infinite. The chrome tanning process is somewhat different from the tanning process as indicated at the diagram shown. The prepared skins are pickled in a bath of salt and sulfuric acid. The pickled hides are soaked with a solution of sodium dichromate. The dichromate-saturated skins are treated with sodium thiosulfate in the reduction drum. The chrome salt is set on the fibers by adding borax to the skins in the settling drum. After washing, The leather is ready for the finishing operations. Water supply and disposal. Since approximately 250 gallons of iron-free water are required for each hide produced, water supply and disposal are very important factors in tannery location. As in most other fields of industrial endeavor, there is no standard treatment in the tanning industry of waste disposal because of wide differences in local anti-pollution regulations as well as in type of processes. Because of the relatively high solids found in tannery wastes, some form of precipitation and sedimentation is usually included. Gelatin is an organic nitrogenous colloidal protein substance whose principal value depends on its coagulative, protective, and adhesive powers. Water containing only 1% high-test gelatin by weight will form a jelly when cold. Glue and gelatin are closely related. Indeed, glue may be looked upon as an impure gelatin. Both are derived by hydrolysis from collage. As you can see at the reaction, collagen plus water is equals to gelatin, and gelatin plus water is equals to semigluten and hemicollin. The industry recognizes three different kinds of gelatin: edible, photographic, and inedible. Gelatin has recently become a widely consumed food. Gelatin is also used by pharmaceutical houses for making capsules and as an emulsifier. Gelatin has played an important part in the rapid development of the motion picture and photographic industries. All three types of gelatin, edible, inedible and photographic, produced are made from calfskin, pigskin, or animal bones. These materials contain approximately 1/3 collagen by weight. Although producers do not agree on which raw material yields the greatest quantity of gelatin, it is known that only the best grade raw materials, such as calfskins, are used for the production of photographic gelatin. This is the diagram in the manufacture of gelatin and glue. The bones and skins frequently undergo a pretreatment which makes the gelatin preparation easier. They are usually heated in lime and water to a temperature of about 70 degrees Celsius. For a short time. When bones are used as a raw material, they should be degreased. This is done by heating the bones under steam pressure and then running off the grease layer, or by extracting with the low-boiling petroleum naphtha. The bones are then crushed and enter a battery of 4 or more wooden tanks in series. The calcium phosphate, carbonate, and other mineral matter of the bones are dissolved, leaving the organic matter, collagen, with the residue from the bones. This is now called ossein. The ossein or hides are washed in a rotary drum or conical-shaped washer, once with fresh water then with slightly acidified water to adjust the pH for optimum hydration of the collagen. The next step is a series of extractions, which are usually performed in wooden tanks equipped with steam coils. The gelatin is filtered, evaporated. The cooled solid gelatin is removed from the mold. These slabs are spread on nets which are stacked on small mobile trucks and pushed into a drying tunnel through which filtered air. On drying, the slabs shrink to a thin strip which may be ground to a powder for further usage. This is the diagram of the different byproducts of the process. Skin raw material can produce hide glue and gelatin. Hide glue has a byproduct of tankage and grease. Bones can be degreased or greened. In degreased process it can produce bone glue and gelatin, while green process produce only green bone glue. This is the examples of glues or adhesives. Protein adhesives. The most popular adhesives because of their stronger, more flexible films. These are made chiefly from waste products of the meat packing and tanning industries. Example of this is fish glue, soy glue and casein glue. Starch adhesives. Starch adhesives or glues were first found in large-scale industrial application approximately in the 1910s. The chief kinds on the market today are made from cornstarch, tapioca flour, wheat flour, cassava starch, and potato starch. Starch adhesives may be applied cold and do not have the undesirable characteristic odors of some animal glues.